I'm going to say in my desktop, let's just show the current application. Meaning, here's my website now. Okay, so you guys aren't in calculus. At least not yet. So, in that case, let's go back. We're on the website, and here we go. Good morning, Jonathan. Go to 227. And in Math 227, you're going to go down here. You're going to notice you have something called online transition. Okay. So when you click on online transition here, I put up a bunch of notes for you on the web. I hope if any of you guys have gone on Canvas, please let me know. I also post these in modules on Canvas for you. Later during office hours, we're going to have our office hours on Canvas. And that way we can communicate, we can talk. Here it's just chatting, writing things down. But office hours we're going to have in Canvas at the same time, 10:30 to noon every Monday through Thursday. And that's going to be, a little bit better, I guess, for communication. So any questions you have there, you just let me know. So what else we want to say here on this stuff? Okay, I did post these notes as well in Canvas for you guys. And I'm going to do duplication of things. I'm going to post your notes here. I'm going to post some of these videos. They're going to still be on my channel. So I encourage you guys, if you haven't subscribed, subscribe to my channel. That way you can actually comment, which is good. And okay, what else? Yeah, subscribe to the channel. We're going to post the notes here in my website in our transition. You can see already there's a list. This isn't all the notes that'll be there. There'll be some more. I'll put a link here to the YouTube channel videos in case you miss or you want to review. And also I'm going to put some PDF files as further examples for you and notate some of the homework as well. So anyway, that's kind of what's going on. So here's your page, and here's all the work, okay, that we're going to start to put for this remainder of this course. Now, let me do a few things here. Let's go through that list and see who's here. We're not taking roll, but let me move this around. Okay, so it looks like I'll go through a quick list here. So good morning, Michael. Good morning, Matt. Jonathan, good morning. Annabelle, good morning. Xiang Chen, good morning. Cindy Chun, good morning. Leonardo Gonzalez, good morning. Paola, good morning. Ileana Magana, good morning. Cassandra Vasquez, good morning. Benjamin Mateo, good morning. Alejandro Gonzalez, good morning. Leopoldo Gutierrez, good morning. Cassandra Vasquez, good morning. Having a hard time finding me. Don't know. I've been. I'm not sure. Okay, I'm here. I don't know. Maybe on YouTube. Maybe that's what you mean. Luigi Rodriguez. Luna Yvette, good morning. Good morning, Matt. Good morning, Jackie. Good morning, Carla. Good morning, Jocelyn. Good morning, Blanca. Good morning, Raphael. And anyone else that comes in a little later, good morning to you guys. So anyway, we're going to start this lecture here, and I want to kind of go back here to the page that I'm talking about. Even though we worked on conditional probability, we did that already. And I want to click this link here. Now, I don't want you guys to, let me get rid of something here. Okay. So what I have for you guys is sort of a review. Since we already did conditional probability, I thought it might be a good idea to go back and review a few things. And what I also see here is an opportunity to talk a little bit about, I don't want it to be dark. I wanted to change the example, but maybe this is a good opportunity to start talking about some of these things because it's something that we could use as a learning moment. And it's actually directly related to conditional probabilities, things that we've been working on. So take a look at this note. It's on Canvas. It's on my website. This is where we're going to start. Um, Conditional probabilities is the probability of an event given a particular condition. This is explored as a conditional probability when we want to compute the likelihood of events given. And I guess that's a little redundant, so I'm going to have to correct that. But what I'm going to look at this morning is a fictitious sort of example of the COVID-19 matter. And I'm going to say that it's not to be taken lightly, but I'm going to use made up data. Now I can change this in the future just because, people kind of want to get away with some of these things, but it's probably good to educate ourselves here. Now, you guys remember what you should be doing at all cost is simply washing your hands and not touching your face. Okay, so we want to remember wash your hands with soap and water. That kills the virus. It doesn't have to be alcohol. It's just soap and water can kill that virus. So that's why they want you to constantly wash your hands and never touch your face, right? Definitely not with dirty hands. So make sure you do that kind of stuff. And anyway, so we're going to look at how this is really used here. So I'm going to go here. I'm going to say, again, this is following data. It's fictitious, meaning not true. So I simply made up some data, some information here. And as you guys can see, what I have here is a sample of 500 who were tested for COVID-19. And we have our table. So let's kind of enter some of this data here if we can. And I'm going to find that sheet. I'm going to kind of enter some of this data. I'm going to go into Microsoft Excel and remind you guys what we need to do. So let's go to Microsoft Excel because we're going to ask these kind of questions, right? Using our definition of probability, we can answer some fundamental questions using data from this table. If you select a person at random, we're going to kind of warm up this morning by what's the probability that the person is infected, is not infected, test positive, and test negative. So what I'm going to say to you guys is I'm going to ask you guys to take a few minutes here. Take a few minutes to start to answer some of these questions here. And what I'll do is really, I'm going to go into open Microsoft Excel, and I'm going to try to enter this here for us and try to see what we can do. Okay, we're going to answer some of these questions this morning. So I'm going to ask you guys to do that, and let me see if I can figure out a way to do that without you. It's not a bathroom break, but let me give you guys a few minutes to try this out on your own, okay? And I'm going to do a few things here. I'm going to go to Microsoft Excel. All right, let's try to see. I'm going to enter the data. Enter the data as we see it. And we have infected. We have not infected. Of course, we're going to make it bigger so you guys can see. Okay. We got 15 here for the first column, 105. And then we got this 18 here. We got 362. Okay. Then down here, another total. Okay, so it kind of looks like what we see here. Now, let's see if we can view here. We want to zoom this. And I'm thinking making it even bigger. So let's zoom this even bigger. Okay. Hi, Paula. We're going to try to find out whether we have a class tomorrow. We're going to have to find out together. I'm not quite sure. I know they moved the holidays around, and we'll see what they end up really doing here. Okay, but I'm not exactly sure. Anyway, all right. Let's see if we can. Let's see if we can make use of some of this information here. Okay. So let's do this here. Okay. So if some of you guys didn't have that worksheet, it's the conditional probability. And I'm going to, and so here's the worksheet now. So here's this particular worksheet. Here's some information, right? So we're looking at this, and I'm going to kind of maybe move this to the left here, minimize it for now. Okay, so what I did was I imported here the data you guys see. All right. And as you guys know, we need the totals here, because if we're going to use our definition of conditional probability, we need to actually use the totals, or even just probability, period. So I need these totals, so I'm going to sum. So I know that the number that tested positive is 120. We're going to sum. The number that tests negative is 380. And now we're going to sum the rows. This is the total that were infected with 33. And then this row here, okay? And that's 467. Now we're going to have the total in the sample. And the total in the sample here is 500. So let's double check here. So I want you guys to double check and notice here that this information that I have on the website, this worksheet, it's in Canvas, will answer this kind of question that Michael Salazar has a question. Would you like you guys to have the website worksheet open at the same time? It'd be helpful for you. That might be helpful. But what I'm working at is this example, reviewing our definition of conditional probability. So this is what we're working on here as an example. And I just want to make sure that you guys have the same table to work with. Because what they're going to ask us is, for the first question, right? What's the probability that somebody is infected? Second question, what's the probability somebody is not infected? Right? Third question, what's the probability you test positive? Fourth question, what's the probability you test negative? So using this data now, we're going to start to answer some of these questions. Let's see if we could do this here. Let's see if we can remember some basic definitions of probability here. So I'm going to go to my iPad here. Right. First, I'm going to try to go to the iPad. I'm going to make sure. There we go. Here's my iPad. I'm also going to bring in briefly here what we're talking about. Okay, so here's that table information. And question 1, they want to know what's the probability a person is infected. Now, this is fictitious data. You guys remember the definition, right? The definition is the number that are infected out of the total in the sample. Now, at this point, some of you guys say, oh, I can't see that. Okay. So we did need to know, or we do need to know how many people are infected. So go back to your table. Now you say the table's right here. Well, by this chart, the first row, infected, we find that there's going to be, again, what? This number is 33. The first row is the total that were infected. This is just a regular probability as a warm-up. The total in the sample, they told us, is 500, but we also can see that in the lower right corner. So if I go back to now my Microsoft Excel here, this row here, this value is the total that's infected, and then this 500 is the total in the sample. So 500 is the total in the sample. 33 is the number that are infected. These are what we're going to work with. So at this point, we need to divide 33 out of 500. And I want to go back and let's say, okay, 33 out of 500 now. We're going to try to find out here what this is going to be for us. Now, the question people always ask at this point, remember, is where do we approximate? It doesn't even say. And you're right, I left that out. It didn't say. But what I'm going to tell you guys now, we're going to approximate this to the tens, hundreds. Let's go out to the thousands like we usually do. So as I give you guys some instructions, we're going to go out to the thousands. Now, there's another thing I want to show you guys here. I do have your TI. So we have the ratio of 33 out of 500 to the nearest thousands here. And when I go to the TI, I'm going to clear out some information. So I want to put 33 divided by 500 to the nearest thousands. And automatically, this answer gave us an answer to the nearest thousands. That's an exact answer, or I guess. Sorry, it is exact. It's 0.066. So here, 0.066, we say, okay, I want to go write this down. This is the probability of being infected. And as you guys know, this represents a 6.6% rate. Okay, this is of the sample in the table. Now, this is fictitious data. It's not true. We're just looking at this as a setting, as an example. So let's remember, this is how we actually answer questions with probability. We're not even conditional probability yet. Now, the second question, so we know, so probability you are not infected. And let's make sure that that's really what they're asking in the second question. And you go, well, where is that? Here we go. Second question. Yes, what's the probability you're not infected? Now, there's a couple of ways, if you guys remember, we could do this. I'm going to use the complement. That the probability of being not infected, remember, this is the complement here, not. That's 1 minus the probability of being infected. So by the complement rule, I can say, oh, is that equal to 1 minus the number we just got, which is 0.066? The answer is yes. And we got to find what this is numerically. So I'm using the complement rule. And if you guys forgot what that was, here's a good time to remember that the probability of a non-event is 1 minus the probability of the event. That's what we just used. And this is the complement. Remember that symbol? So we need to know what is 1 minus 0.066. So I'm going to go to my TI calculator and say, okay, if you guys remember, we have 1 minus, we can do previous answer. See, in the lower right corner here, we got answer, previous answer. So I hit second answer. That was always the previous answer. Or I could just put 0.066. When I subtract, I get this equal to 0.934. So 0.934. So I'm going to go to the iPad and I'm going to say, okay, this is 0.934. This is the probability of not being infected. And numerically, if you guys remember, or as a percent, 93.4% of the sample is simply not infected. Now, that's just dealing with the table regarding infection. And that's kind of, what we care about so far, right? And then if I say to you, well, go to question number 3 in this sheet. Question 3, they want to know, what's the probability a person in the table tests positive? Now, I want to remark something here to you that's really important that we're kind of getting at with conditional probabilities. You're going to see this. This is the trend. This is how we're lecturing. With this content, it catches your attention because it's dealing with you with your daily life. Now, I'm looking at this table and saying to you, let's go back, Microsoft Excel. We're looking at the table. And you say, this is kind of a bit confusing because some people will say, hey, and let's kind of clear this up. I want to be consistent here. Infected. Okay? I'm going to put these numbers back. Wow. There we go. So we're looking at this table, and I'm going to remind you guys that in this demonstration, or I should say in this table, people weren't just tested once. They were tested at least 2 times because they found all the errors. So they're finding errors here. Now, it's true if you say, if you test positive, does that mean you're infected? No, it doesn't necessarily mean you're infected. I should say it doesn't guarantee you're infected. And we're going to really explore that question. If you test negative, does that mean that you're not infected? No, that's not a guarantee either. But for the sake of these questions, we're looking at the probability now of somebody just testing positive. So question 3, what's the probability of testing positive? Question 4 is going to be, what's the probability of testing negative? So I'm going to go through this. Now, we have a question from Leonardo Gonzalez saying, can you re-explain the steps for question 2? I can go back to do that, but what I want to do is let me show you 3 and 4 because there's going to be similar steps. And what I mean by that, you're going to see the complement rule. So let's look at this first definition of probability of testing, we should say, being positive first. And we're going to go now to the iPad. And remember the definition of a probability. That's the number who test positive. Now maybe we should, yeah. It's the number who test positive divided by the total in the sample. Okay, so we're going to look at this table again. And reading the table, the first column is the testing positive column, which you know the total that tested positive here is 120. So I'm going to replace this total with 120. The total in the sample now, if we go back, is still 500. This is 500 people that we actually asked. So this total will be 500. So what we're looking at here is 120 people test positive out of 500. We want to know what this is equal to or is approximately to. So this is our first kind of warm up trying to find these probabilities. So we're going to need to go to our calculator. And in the calculator now, we're going to have to clear some things, right? Since we need to know 120 divided by 500. Well, that's actually 0.24, and that's exact. So this equals 0.24. That's a probability. Now, some of you guys may remember that this is actually 24%. So in this table, we're going to see that 24% actually test positive. That's all this means. I'm going to move this out of our way. Okay, so 120 out of 500 is 0.24. And 24%. Okay, now this is going back to Leonardo's question here. It's very similar. So Leonardo, let me remark here. Question 4, they want to know the probability that you test negative. Well, the probability you test negative, we write as 1 minus the complement, right? By the complement rule, if you guys recall. We can write the probability of an event is always 1 minus the probability of the non-event. This is the complement. This is a symbol for the complement as well. So if I say to you, what's the complement of testing positive? So if we go up here, you test positive. What's that complement? Oh, you test what? Sorry. The complement of testing negative is testing positive here. It's a logical opposite. You can either test positive or you can test negative. So using the complement rule here again, we can say if I want to find the probability of testing negative, I just need to know the probability of testing positive. I take that 1 and I subtract that. While the prior question answers this question, it's 0.24. So this is going to be replaced here with the 0.24. So we can now look at 1 minus 0.24, and we're going to get our answer. So we're using the complement rule. Now, let's look at this in our calculator here and say, okay, TI. Since it's already located in there as a prior answer, I can say 1 minus prior answer. Excuse me, or I could put 0.24. So let's see what that is. This is going to be 0.76 as an answer. So I get 0.76. That's the probability of testing negative. And as you guys remember, this actually means 76%. So let's think. If 24% test positive, the opposite of that, right? Here's your 24%. The opposite is 76%. So this is how we answer those first questions. Now, let's go back to see what Leonardo says. Oh, yes, I see your point, Leonardo. Well, question 2, they ask, what's the probability of not being infected? We still use the complement rule. This is still complement. Non-E and E. So we have actually 2 versions, really 3 versions of the complement rule. So the probability of non-infection is 1 minus the probability of infection because these 2 events are complements, right? This event here and this event, they're complement. You can either not be infected or you can be infected. And I'm going to recommend we start to use the complement rule because of the fact that it's very useful. The definition could have been used here. It's not the issue, but let's start getting used to the complement rule. And this is how we started as our warm-up for these probabilities. All right, now we're going to go further and say, okay, so what's going on now with this worksheet? Well, if we go back to where the worksheet is, and we say, okay, here's the worksheet. We have additional questions. Now we're going to have our conditional probability. So down here, we wrote it in terms of the letters A and B. The probability of A given B equals N of A and B. So now they're saying if you select a person at random, what's the probability that the person, now take a look at these examples. We got questions 5, 6, 7, and 8. Now, we got a question from Cassandra. Cassandra says, so you get the answer from the prior problem and just use the complement rule. Cassandra, absolutely. Complement rule is going to be your best friend. But you have to know what opposites are, right? If you have only 2 events like testing positive, the opposite's going to be testing negative. Okay? Opposite of infection is not infection. The opposite of up is really not up. Okay, the opposite of right is really not right. Now, not right can be a lot of things. So we're really working with the complements. And the answer is yes, Cassandra. You're going to need to use the complement rule here because you're going to see shortly it's going to be our best friend. Okay, a few other things now. Let's go to our conditional probability. Now, we did conditional probabilities in the past. Okay, conditional probabilities. Okay, let's see about this here. Question 5. What's the probability that you are infected given that you test negative? Okay, so here's the situation. Here's the question. All right, question 5, probability you are infected given that you test negative. So let me go back and write this down. Make sure you guys have this definition. I'm going to write it down here for us, but I'm going to go to the iPad now. So here's question 5. The probability you're infected given that. Remember this phrase, given that. That tells you you have a conditional probability. What comes next here, that you test negative, this is called your condition again, right? This is the condition. This is what was known. This is what's happened. This is what we have that's certain, meaning somebody just tested negative. Now, like I said, there's errors in our testing. So when I write this down in terms of probability, remember the definition. The probability of A given B is N of A and B over N of B. And this part here, this line represents the phrase given that in our notation. And here's my B. Okay, this is the condition. This condition is somebody tested negative. Well, by definition, notice this here. We're not dividing by n of s again. That's n of b. This is a conditional probability. So what is certain for us is that somebody just tested negative. So if you test negative, believe it or not, you can still be infected. So the probability that you are infected, we don't know, given that you test negative. That is known. We have to look at our table and we have to find the number that are infected and test negative. I'm going to write down the whole word. Divided by the total that test what? Negative. This is using our definition. So remember, definitions are key to a lot of things. So I'm going to go back to our table and we're going to try to see if we could deduce this information from the table here. So I don't know if you guys can see this. Let's see if you can. I'm going to click on the document. Nope. Let's click on this document. There we go. Finally. And let's try to read this. We need to know how many are infected and test negative, right? So it could be that maybe we should go to Excel. How many are infected and test negative? So let's see if you guys can see that. Okay. Get rid of that. So let's find where you're infected and test negative. So I'm going to go back here to this and say, okay, change these colors so we can find the right colors for our definition. So infected and test negative. This is the column right here. So we need the infected row, test negative column. That's right here. This is 18. And then we need to know how many test negative. So testing negative is the negative testing negative column. It's right here. So the ratio is going to be 18 over 380. Okay, so this is what we have to find. 18 divided by 380. So 18 over 380, let's go to our calculator and say calculator, 18 divided by 380. This gives us 0.4736. So let's make sure we start to write down all these answers. Remember, this morning, even though it doesn't say in this sheet, we're going to approximate to the nearest thousands. So when I go to my iPad, let's try that out. We have replaced this numerator with 18, the denominator with 380. So we have this equal to 18 over 380. This is approximately, we have 0.047368. Let's remember, tenths, hundred, thousands. We put the arrow under the 7, put the eyeball next to the 3. If that 3 here were a, well, let's just say if that digit was a 5, 6, 7, 8, or 9, we add 1 to the 7. But if it's a 0, 1, 2, 3, or 4, in this case a 3, we leave it alone. So meaning our approximate answer is 0.047. Now this here again is a probability. As a percent, for this conditional probability, this is 4.7%. And let me remove this so you guys can see my point. I apologize here. Yeah, let's make that really tiny. So let's go back again. Remember, for the approximation here, we have tenths, hundreds, thousands. So the digit is in the sevens and the thousands position. We look to the digit to the right, which is a 3. That means leave the 7 alone. If it were a 5, 6, 7, 8, or 9, you add 1 to the 7, and it would be 0.048. It's not. It's a 3, so we leave that digit alone, and we discard the 3, 6, 8 here. So this is about 0.047, or we should say 4.7%. Now, ladies and gentlemen, this is a conditional probability, and here's my point. Just because you test negative, that's the condition. This is what's known. Somebody tested negative. There's still a chance that you are infected. And in fact, this chance is about 0.047 or 4.7%. So you got a 4.7% chance of still being infected. Okay, this is known, by the way, because you say, wait a minute, I don't like this idea. I just tested negative. Well, we just tested negative because of the fact that, what's the deal? Right? We can still be infected. So that's the first thing I'd think to myself. I just tested negative, but there's a chance I'm infected. This is known, by the way. This is, if you guys remember what we call this, let me remind you what we call this. This is called a false negative. It's false because you're actually infected. The negative portion means, well, you tested negative. So there are false negatives. There's also false positives. And we're going to see that. Now, we got a question here from Leopoldo. Says, how do we get the 380? Well, go back to the definition. Let me move this down here. 380. Let's double check. By definition of a conditional probability, right, we need to know N and B. N and B, the condition, right? Here's that condition. The condition here is testing negative. So we have to know the total that tests negative. So let's go to this little sheet here and see that what's the total of testing negative? It's 18 plus 362, which gives you 380. So if I went to, for example, Microsoft Excel, right, the 18 here, plus 362, that gave us the 380 here. This is this column here. 380 is the total that tests negative. That column. Okay. Let's look at the next question here, right? The next question is another conditional probability. Number 6. Which probability you're not infected, given that the person tests positive? So I'm going to write this down here. You guys can't see it just yet, but I'll write it down anyway. They want to know the probability you are not infected, given that you test positive. Okay? This is question number 6 that you guys see in our notes here. So let's move this way over here. Okay? Now notice this is a conditional probability, and you say, why is it a conditional probability? Because the phrase, again, given that. And then I would say to you, okay, what's your condition? What has happened? What is known? That's right here. That's your condition. This is known. This is certain. This has happened. So in your definition of conditional probability, right, the probability of A, given that B is N of A and B out of the total in B. Now, here is what's going on. To use this definition, they're saying, what's the probability you are what? Not infected? Okay. Chance you're not infected. This line means, again, given that, right? With that vertical line. And now I have my condition. I'm going to put that condition in red. You just tested positive. This is the symbolic version of the question. So we can say, okay, we know this by simply answering the number that are not infected and test positive out of, not N of S, the number that tests what? Positive. This is applying the definition. Your condition again, right here, testing positive, goes here and here. So stop and think. You could get tested for the coronavirus or really anything else, any other virus, any other condition, and you could test positive. That does not mean you're infected. You could be infected. You may not be infected. We don't know. But you tested positive because there's errors in every test. And so these errors are really what we're looking at. And so you say, okay, I just tested positive. What's the chance I'm really not infected? Well, we can compute that, but we're going to have to go back to the table. Now, this time, as opposed to the last time we needed to know how many tested negative. This time, we have to know how many test what? Positive, because it's a different condition. So let me go to our sheet again. We'll put it right in the middle here. Got to go to the data. And remember, by definition, we need to know how many test positive, right? So you're looking at this chart. And I'm going to say, okay, I can see from this chart that 120 people tested positive. And you go, okay, how do you know that? Well, let's go to Excel. We don't need that data. This time, we need to know how many test positive because we're using the definition. How many test positive mean the total who test positive? That's 120. So that's my denominator. Now, remember, what's the numerator? That's the number who are not infected and test positive. So I go to the non-infected row. It's right here. And I have to go to the positive column. It's right here. So tell me, non-infected row, test positive, non-infected row, test positive. What number is that? That's 105. So I have to take that ratio of 105 divided by 120 to find this conditional probability. Okay, 105 divided by 120. So let's remember that. It's also in this sheet. You can see it here. Okay. Okay. So remember that 105 is the numerator and 120 is your denominator. So this equals 105 over 120. Let's see what this is approximately. Where's our calculator? We can clear some of this. 105 divided by 120. See what we get. Well, this is not approximate. This is actually exact. So this is going to be 0.875. 0.875. So if we go tier 2, write it down. The conditional probability is 0.875, which really means 87.5% are actually not infected, given that they test positive. So let's consider what this means for us, because this is also important, right? It is known you tested positive, and you go, oh my gosh, I got a positive test. That doesn't mean you're really infected. In fact, here, the chance that you're not infected is actually 87.5%. That's not very good. Okay, so let's double check this. Not infected and test positive over testing positive. Okay. So this is how we answer this conditional probability. Now, as you guys can guess, this is probably called what? This is a false positive. Oh, I'm sorry. Let me go back. Well, this is a chance you're not infected given that you test positive. Okay. So if we go back to our worksheet, apologize here. Let's see what we have here. Probability you're not infected given that you test positive. Yep, it's called a false positive. So let's write that down. So especially if you're going to go into the nursing field and you're even thinking about some of these things as it pertains to your daily life now, we have all these various, these are all conditional probabilities. This is what I'm saying. Conditional probabilities are my favorite probabilities because they answer a lot of questions. The next question here that we're going to have now is if we see number 7, right? What's the probability you test positive given that the person is actually infected? So here we go. Here's our phrase given that. That means we have a conditional probability, and you guys can't see that. I apologize. Okay. Here's our conditional probability. The condition here is being infected. So when I use my definition again, right, I'm going to write this way. This is the probability. Now, I know my definition. Here's the event. What's the chance I test positive? Here's my phrase given that. Now, my condition here is being infected. That's equal to the number that test positive and are infected out of the total that are infected. So again here, I have to go to my information to use the definition. Please note the condition, what's happened. We know somebody's infected. They're infected. They're infected. That's where the B portion goes. That's where the condition goes. We want to find the chance that they actually test positive given that we know they're infected. So we have to go to the table and we have to look for this piece of information. So if I go to this table again, and let's make it bigger, and it's actually on a prior page. Okay, so look at the chart here and we say, oh, okay, we didn't know this time how many are infected. Can you guys read how many are infected? How many do you think are infected just by looking at this chart? Right? What's the total infected here? Well, let's go back. Total who are infected. Of the infected people, that's row 3. So the answer is what? 33 people are infected. But we also need to know of the infected people, how many also test positive? You're right, Cassandra, 33. So of the 33 people that are infected, how many also test positive? Yes, Joanna. Right here, this column. Test positive, infected. Test positive, infected. Test positive, infected. It's right here. It's going to be 15. So we need to take the ratio of 15 out of 33. Okay? 15 out of 33. So I'm going to go over again to our iPad. Remember, 15 out of 33. Oops, sorry. We know 15 out of 33 That's the probability. Let's see what this is numerically, because we like to talk in terms of percent. And we're going to look at the calculator here to do that. All right. So we're going to say, okay, KTI. 15 divided by 33. Now here's what we have here. Essentially, you have 0.45454545 forever. Yeah, and actually, you're right, Jessica. This is going to be the answer. But remember, we're going here to the nearest thousands, so we need tenths, hundred. Oh, here's my thousands position. My eyeball is a digit to the right, so this means 0.45 tenths, hundred thousandths. Actually, let's be careful. 0.4. Yeah, it's actually going to be 0.455. Is that right? Because the 5 means add 1 to the 4. Remember, the digit you're looking at right here, this 5. If it's a 5, 6, 7, 8, or 9, add 1 to the digit in the thousands position, and that will make it 0.455. Now, as a percent, since we communicate that way, this is 45.5%. Okay, good job, you guys. Okay, so this is number 7. Now, notice what's happening. It's certain the person's infected. This is known. They're trying to measure the chance that you're actually testing positive. That's 0.4545. And so, as I can say here, if we go here to the definitions, number 7, this is actually known here as a true positive. So I'm going to write this down here. This situation is called a true positive. You're infected, and the test result reveals that it's true. So as you guys can see, that there's not certainty here. There isn't certainty. It's not a probability of 1. Okay, certainty would be, and that would be a very good test if that's the case. If you had a test that's probably a 1, that's amazing. But you don't have those. It could be close to 1, could be almost certain, but every test is unique. Every test is different, has a different what's called sensitivity, a different okay, we'll leave it at that, sensitivity. And our specificity, I can't say it this morning, sorry. Let's go to question 8 and look at another conditional probability that I have in our notes, something that we should be very aware of these days because we might get tested one day, hopefully not. But question 8, they want to know what's probably probability a person will test negative, given that the person is actually not infected. Okay. So our condition in this question, number 8, given that, and I know you guys can't see this, and here's our given that, here's our conditional probability. The condition now, what's known is that you're not infected. Now you're thinking I should test negative. You're right, but there's errors here. We know you're not infected. So this testing negative should be 100%. It's not. There's errors here. So when we write this down, probability, you test negative, given that you're not infected. Right? It should be 1. It isn't. So the number that tests negative and are not infected out of the number that are not infected. So you guys want to remember this here. This is a conditional probability. Your condition here is not being infected. This is why we divide by the number who are not infected. And I want to remind you that's where your condition goes as well in your definition. We can answer this question if we look at the table here. So in this case, we need to know the total, how many are not infected, and then of that total, how many test negative. So let's look at this here. And this is question 8. So let's go back. Say, okay. So we need to know how many are not infected. So you have to look at the table and tell me, you guys, how many are not infected. I'm going to go to Microsoft Excel. I'm going to show you how many are not infected. So we don't need this information. And we don't need this information. Again, we need to know how many are not infected. We go to the non-infected row, and that's the total they want to know. So there's 467 people who are not infected. Similarly, we need to know how many tested negative. So we're in the not infected row, test negative column. Not infected row, test negative column. That's 362. So to summarize, that's 362 out of 467. So when we go to our iPad, we say, okay, this is 362 out of 467. We want to see what this equals as a decimal. Maybe you guys can tell me, right? 362 divided by 467. And here's what we get. 0.7751605. And let me be a little bit clearer. So the 5 is in the thousands position. We know. And we look at the digit to the right. That's a 1. So what's our answer? As a probability, it's 0.775. And then as a percent, this is 77.5%. So notice, ideally, we would want this to be certain. 1, because after all, what just really happened? We know you're not infected. So the chance you test negative by this particular test is actually, it's not certain. It's not 100%. It's about 0.775%. So let's go back and remember what some of these definitions are. Looking at question 8, if we go here, I guess maybe it's over here. Question 8, what is this known as? Remember, you're not infected, so the test should be negative. This is a situation is known as, we call this a true negative. Because the test should actually reveal truthfully 100%. We know you're not infected. Your test should be certain that it tests negative. So this measures really the sensitivity of our testing in terms of any virus, any illness. It could be a pregnancy test. It could be a marijuana test. They want to test you. Any sort of test that's done on you has the built-in errors. And what I'm showing you guys here is all those errors. And that's the essence of this kind of lecture for conditional probability. It's reviewing the definition of probability and these other things. Now, I do have some additional questions here. I changed the setting to the cards. Now, you guys might remember from some of your notes that we did this. And what I'm going to do probably later today is I'm going to do these on a sheet of paper, and I'm going to upload them to my website and Canvas probably to finish this setting off. And I want you guys to review that. Okay, I want you guys to review the rest of these questions. And I might even say to you, hey, for homework, you guys have to do the rest of these questions. Okay, that's for start. But I actually already gave you guys some of this homework already. Let me try to go to my website and see if you guys remember. I'm going to go to my website here. So let's see. I got to go to, oops. Let me go to here, desktop. All right, I'm going to go to my website. This is what I'm talking about. Conditional probability. I'm going to put the video link, and I'm going to put some worked examples from this. And then I'm going to say to you guys, let's go back to this lecture. Some of you guys said you might have done that already. I heard this already. So for your homework, you say, what's our homework here? Remember Statistics Lecture 6? This worksheet? So for your homework, I want you guys to do Statistics Lecture 6. Let me put that here on the iPad. Homework. Statistics Lecture 6 from the web, and I'm going to probably send you some book work later too. Okay? So probably send that as well, and that's going to be, again, what you have here. Now, here's some good news. I'm starting to get some questions here since we're running out of time, and you guys probably have to run over across campus to get to your next class. It's a joke. You guys can laugh. Okay? Well, that's not exactly a laugh. That's just an applause. There's a laugh. There you guys go. Now you guys are laughing. That's good. Homework Statistics Lecture 6 on my website. Some of you guys finish that off. I'm going to finish some more examples here for you and post it on my web, post it in Canvas. If you have any additional questions, since we're out of time, I'll be in my office hours in Canvas like we described. Okay, so we'll also try to find out when our next lecture is. Okay, hopefully it is tomorrow. I'm ready to go. I'm tired of sitting home. I want this Corona stuff to be over. But anyway, we'll find out. And I want to say to you guys, stay safe. Okay, stay safe. Wash your hands. Don't touch your face. That's important. And keep your distance from people. Okay, I wish you guys well. We're going to get through this. And, I'll see you when I see you. I'll make an announcement as to our next lecture as soon as I find out if tomorrow is a holiday or not. If you want to watch the video for Statistics Lecture 6, you can. If you want to rewatch this lecture, you can. It's going to be on my channel. It's saved there for you guys. I'm also going to put a link on my website, so it'll be there for you guys. Okay? Yes, you can rewatch. Raphael, it's going to be available for you to rewatch. Annabelle, I don't think the math lab is quite open now. I think they're going to do it virtually as well, and I think it's in a few days. I think it's in April, like 1st, 2nd, or 3rd or something. Okay? And homework, Statistics Lecture 6. Recap. Okay, you guys. If you have any questions, see you in office hours, and take care.